FAIR, which is... Okay, so I'll just start again for the recording. So, yeah, just talking about FAIR, which has already had a few mentions in the presentation today. So, just sorry about this. There we go. Okay, so the FAIR principles for research data management were published in 2016 and related to making digital assets findable, accessible, interoperable, meaning that they could work across different platforms, and also reusable. Another key part of the FAIR principles is that they're designed to work for both humans and machines, so to be human readable as well as machine readable. Also, just to say right at the outset, in terms of sensitive data, accessible does not necessarily mean open for everyone to access in the context of open access like you would encounter for journal articles that anybody can read. FAIR has a lot of overlap with open, but it is different. Sensitive, restricted access data can still be FAIR. So one phrase that's already been said this morning is as open as possible, but as closed as necessary. So FAIR data is just great for enabling reuse, but more specifically, it can accelerate collaboration between research and industry because it enables others to easily find, understand, and use your data. So whether you're from a university, government agency, or an industry partner, FAIR enables you to gain maximum potential from data assets and achieve maximum impact from your research. It also increases the visibility of your research and can lead to more citations, if citations are one of your indicators. It improves the reproducibility and reliability and trustworthiness of your research. It can help with attracting new partnerships with researchers, business, policy, and broader communities, and enables new research questions to be answered and societal challenges to be met. So our first is F for findable. So these are the principles here from that 2016 paper, so F1 through to F4. You'll notice that in 1 and 3, it's got the meta in brackets. So those principles are referring both to the actual data and the metadata describing the data. So just so that we're all on the same page. So the metadata is the information describing the data. I come from a background, I think of it as metadata as a library catalogue entry. So you can see things like the author, the title, place of publication, publisher, and get enough information to decide if this is something you want to view in full. Same with metadata, only metadata can go so much deeper than a library catalogue record. So our first principle is that the metadata and data are assigned with a globally unique and persistent identifier. So you might have heard of DOIs, digital object identifiers. These are what we want to assign to each data set. The next one is that they are described with rich metadata, and there's different schemas for doing that. So 2 of the more common ones are Dublin Core and also Darwin Core, which is used in biological sciences. Next is that the metadata and data are registered or indexed in a searchable resource. So an example of that is Research Data Australia, which is an ARDC service. There's also lots of institutional repositories. So, for example, lots of universities or CSIRO would have their own institutional repository. And there's lots of subject repositories out there as well. So there was a question that came through about how to get your metadata into RDA, and that question was from CSIRO. The ARDC has automatic harvests set up from several repositories, in fact, lots of repositories around Australia. CSIRO is one of them, so it will be captured in that regular harvest that comes through. There are other ways, so we can pull in your metadata from your repository, or in some circumstances, we can even work together to create a record. It's also a good idea to think about subject repositories and think about where people in your subject area look when they're looking for data sets. So putting in front of the audience and where they're going to search can be a key factor. The last one there is that metadata specify the data identifier. So, for example, you will see the DOI of the dataset on the metadata record. So just to recap, so this is just a really basic introduction into FAIR and the key considerations to be thinking about fairly early in your project, and just to plant a few seeds of topics to explore as they're relevant to your project. So the first step in using or reusing data is to find it. So key points here are that the data should be described well with lots of metadata, lots of detailed metadata, deposited in a repository that's searchable. So Research Data Australia is also indexed by Google. And the repository should assign the dataset a unique identifier. So there's an example. What I'll do after I've covered FAINR is we'll go into this record and I'll sort of tick off with you how it covers all the FAIR principles. So you can see them in action, as it were. So A is for accessible. So remember that while the metadata should be accessible, the data itself does not have to be open. So, for example, it might be if your data is about the location of an endangered species. We come across this a lot in the health sphere to protect patient confidentiality, or in the case of farmers, if it's of commercial value. So if the data is not open, it should at least be accessible through appropriate protocols, and it should be clear how this procedure works. So, for example, you might have mediated access, where a person or an organisation is contacted to request access to the data. And when you're requesting that access, for example, you might say that you've had approval from an ethics committee to do this research. On the technical side, data can be really large and complex. So in the example record we'll look at in a bit, it's got data that you can download as a CSV file. But if it's a really large, complicated data set, it makes sense for it to be machine readable through an API. And this is something a lot of ARDC co-invested projects do. They'll set up an API. Okay, so our accessible principles are firstly that metadata and data are retrievable by their identifier using a standardized communications protocol, which is a really fancy way of saying when you click on the DOI link, it takes you to the record. The next one is that the protocol is open, free, and universally implementable. So that will work with DOIs using just a web browser. Protocol allows for an authentication and authorization procedure where necessary, and also that metadata are accessible even when the data are no longer available. So again, we had a question about that. So that's referring to the metadata record always being available. And when the data are no longer accessible, we call that metadata record a tombstone page. So it's saying this thing was here. You can still see the metadata about it, but you can no longer access the data behind it. So it is just that metadata record, and they do need to be maintained in perpetuity. Okay, so the recap. Okay, so once found, users need to know how data can be accessed. So are there any authentication authorization requirements? Is it as a download, via an API, by another means? Okay. And now we move on to interoperable. I must say, when I was first learning about the FAIR principles, interoperable was always the one I found so tricky because it can get really, really technical. So this is about being able to use the data with other systems and getting it to talk to other systems. And a key method of doing that is using vocabularies and also persistent identifiers, so that both humans and machines are crystal clear on exactly what the data is referring to, for it to be able to talk to other systems. So the FAIR principles are saying that both metadata and data use a formal, accessible, shared, and broadly applicable language for knowledge representation. So data standards come into effect here. We need to know that we are literally speaking the same language. When we talk about temperature, for example, we're agreeing that we're going to use Kelvin, or we're agreeing that we're going to use degrees Celsius or Fahrenheit, for example. We need to specify that, so we're all talking the same language. There's also standardized formats that can make data interoperable. So, for example, using CSV files, which are non-proprietary. Also, that metadata and data use vocabularies and ontologies that follow the FAIR principles. So if vocabularies are going to be part of your project, get in touch with me or Stephanie, because we do have expertise in the ARDC and also tools available to help you create a vocabulary, to make it fair, to publish it, to do things like assign persistent identifiers, not only to the vocabulary itself, but also to each term within it, so that it is truly fair and reusable. Also, that your metadata and data include qualified references to other metadata. So we'll see in a moment when we look at this record that where it refers to, say, other data sets or other articles which they've reproduced those methods used in those other pieces of research, that they have referenced them using, say, DOIs. So it's all understood. Okay, so data often needs to be integrated with other data and work with applications or workflows for analysis, processing, and storage. So when I was at UWA, one thing I would see a lot would be health researchers doing systematic reviews, and as part of that, they will do a meta-analysis. So they found every study they can that's on their topic of interest, and they will pull together the data from those studies to cover a much broader population and to produce more generalisable results, because they have a much larger sample size. So to recap, it's using common standards and formats for the data, and the use of common published vocabularies to describe the concepts in the data. So reusable, the R in FAIR. This is what the F, the A and the I have all been building towards, this ultimate goal of making data reusable. So the main points here are that it's important to assign a clear, standard machine readable license to the data, like Robin was talking about in data governance. So it might be a Creative Commons license, or it might be a different type of license. And even within Creative Commons, looking at the different options that are available. So for example, you might say non-commercial or no derivatives. It's also important to add information about the provenance of the data to the data set, and we'll see that in a second, our example. It gives the reuser a much better picture of how the data was collected, of which instrument, using which settings, the methods used to capture it, and also about the subsequent manipulations that have taken place to the data. So FAIR principles are firstly that there's a license, which we've talked about, that metadata are associated with their provenance, and that they meet domain relevant community standards. Okay, so we implement the F, the A and the I. If there's one thing you remember today, because you've been told 200 times, it's assign a license to your data and the provenance metadata. Okay, so before we have a look at our sample record, I just wanted to quickly talk a little bit more about data standards. So these are documented agreements on representation, format, definition, structuring, transmission, manipulation, use, and also management of data. So they make it possible for data from different sources to be brought together and used by different systems. So for example, there might be some ISO standards, others are community agreed or even common practices. So I've got some examples up there. So for example, the Bureau of Meteorology's water data transfer format, or OGC for geospatial information. Also about vocabulary. So I mentioned these earlier when we were talking about interoperable data. So I really like this example because are they talking about a 6? Are they talking about a 9? Are they talking about a G? Can't tell from that example what they're talking about. But clearly, if we're going to interoperate things, and especially making it machine readable, we need to have a clear understanding of exactly what we're talking about. So we need to get the original creator of the research data to annotate it with vocabulary concepts. So then the data would express itself and its meaning or communicate exactly what it is. And then researchers can understand what it is and have a discussion on the basis of that shared understanding, or at least understand what the creator of the data believed it to be. So vocabularies help research by providing a way of formalising meaning. So these formalisations are published and then can be used and reused to annotate data. So data annotated with meaning helps discovery, analysis, integration, and reuse. So again, if this is an area that your project is going into, let us know and we'll put you in touch with the expertise people at the ARDC. So enough of the philosophy, let's look at something a little bit more concrete to illustrate the point. Now, I'm in WA. If I go to South Australia and ask for a pint, and I don't know that South Australian pints are smaller than WA pints, I might feel a little bit ripped off because the understanding of a pint over there in South Australia is a little bit different to what we have here in WA. Just to give an example. Okay, so vocabularies do sound very, very complicated, which they can possibly be. They can also be way more straightforward than what I've made it sound. And you've probably already used vocabularies and not known it. So a vocabulary is a set of terms or labels that are used to represent concepts in a particular community. So even a dictionary, you could consider an example of a vocabulary. Gazetteers, if you're referring to place names, taxonomies, if you're in life sciences, for those of us in libraries, subject headings, thesauri, and also ontologies. So again, in the medical area, the MESH subject headings are very commonly used in resources to describe particular concepts in a great deal of detail. Okay, so let's look at a real example. So I'm in Research Data Australia here, and I wanted to find something vaguely food related for this morning's session. So I found this entry from the University of Tasmania, which is a data set on global fishing effort. So let's just take a moment to pull this apart and see which fair boxes it ticks. So first thing, access the data. Nice big box, very clear to the user what we need to do. So we go to their landing page, which will pop up in just a sec. And we're at the global fishing effort page. So this record has been harvested into Research Data Australia. So we can see that there's downloads. So we can download the data set as a CSV file. Again, a common non-proprietary format, so great for making it fair, but also open. It's also great to see that there's a README file with a description of data file structure. So this is definitely recommended as best practice. So your metadata will ideally go into a fair bit of detail, but it's good to have a README file as well.
Kylie, sorry, just to let you know, we have about 10 more minutes, and it would be really good to have a bit of time for discussion.
Okay, I'll wrap it up in about 1 or 2. Thanks, Stephanie,
Thanks.
for the time check. And also data sources by country. So again, we can see this is an example of a vocabulary. So these are some keywords that have been assigned to this data set. So if people search for, say, environmental impacts, this record will come up. The FOR code, fisheries management, has also been assigned to it. And we can see that it has been assigned a DOI code, and the DOI appears on the metadata record, which is one of the FAIR requirements. It also has a Creative Commons license, CC BY, and it links through to the information about that license. Again, one of our FAIR requirements. It also has a statement for how to cite the data. Again, best practice. And it has a point of contact, and it has this person's ORCID ID as well. Now, if we jump back to the RDA record, which is actually what I want to show you, our description, you can see it goes into a fair bit of detail, and you'll see it as we go down the screen. And when it refers to other literature, for example, when it's talking about this method described in Rousseau et al., it's got the DOI for that article. It describes the lineage, so how the data was collected, again, the references, and it goes into a fair degree of detail. It describes what's in each file, and even describes what's in each column, and even how it has been manipulated. It also gives you the information you need to be able to reproduce everything that these researchers have done. So if I'm a researcher looking at fishing data, I think, great, I can see exactly what they've done. I can follow up all their references. I can reproduce this. This actually looks like quite transparent and trustworthy data. This is the kind of thing I would consider reusing because I can see exactly what they've done. We also have different relationships in the graph. So different people, organisations, data sets and publications. This one covers the whole world, so probably not quite a good example of the map. Subject headings, and then all our access links, and again, that DOI at the bottom. So yes, that was a very quick example. I've got the link to that in the slide, so I'd encourage you to really go into lots of depth and have a close look at that record and follow up exactly what's there. Just stop sharing. So thank you very much. That was our whistle-stop tour of FAIR.